Hello everyone, hope you're doing fine. So previously they have been receiving a number of clients inquiring how to choose the right solar panel and the brand and the make. And so here are some of the 5 tips I would advise. Of course, you have to estimate the energy demand. So one way to go about it is to keep those records, those SMS which you pay. If you share with us, we are able to give you a good uh, amperage, or we are able to give you a size of the one you need from the data that you have, the seasonality. We're able to predict better off even if you have that data for a number of years. It will help us and guide us. This is very useful, especially for schools. We have done for schools where we'll be able to help them to optimize their energy, and not only schools and hospitals, we'll be able to help them to be able to optimize the energy they use. Because you see, like these schools and hospitals, some of them, especially the hospital, they consume a lot of energy because they have those freezers, and those freezers have to be running all the time. Same case with our homes where we find ourselves, we have those freezers and we don't want to spoil the food, so we run these freezers all the time, and also we have lights and also more. So from your energy consumption, you have to note your energy consumption and expected daily usage hours, and then you also have to calculate the total daily consumption, the daily total consumption. That you get it by multiplying the wattage each the wattage of each appliance by the hours used the daily to estimate the household total daily watt hour. So you get the watt hour or the kilowatt when you multiply by 1000. And then of course also you have to also you also have to optimize solar panel fitting. So that means that in Kenya, for example, you have to know the hours the solar has to be worked. Let's roughly 5 to 6 hours. And then you have to use high efficiency panels. The best ones are the monocrystalline panel, as they perform better in limited space and provide higher efficiency. That is one. So I have been working in this solar, in electrical, in automation, let me call it home automation. We deal also with alarms. You already know we deal with alarms, fire alarms. We also deal with electrical constellation for big farms, electrical automation for farms, and IoT in that kind of sense, IoT, and also AI for those who know. So this is also part of it. IoT and solar automation is for organizations who need it. And so been working in the industry for many years, in the electrical engineering field for many years. So you also have to choose the right inverter. So don't buy crap inverter. Match inverter size to the load. You have to match the inverter size to load. Ensure the inverter capacity is equal to the peak wattage required by the household simultaneous appliance usage. That is a lot of jargon, but in essence what it means that you have to match inverter to the size of the load. If the load is higher, means you have to buy a bigger inverter. Then also the best inverters, you get the pure sine wave. So pure sine wave, which provide clean power output suitable for sensitive electronics. So this is very essential. And of course, you have to ensure you get adequate battery storage. This says without going that, even for a car, if your car has a small battery like a motorbike, it will not run for long. That's why you find vehicles like Tesla, they are so heavy because they have a lot of battery. They have a big battery tank, a bank. So the same case with your solar battery storage. You need to calculate the requirements, determine the ampere hours based on the required nighttime usage or backup load. Then of course it's recommended that use lithium. Lithium is the best. There are others who are using others, for example, self-driving cars. They have come up with others like using sodium. Those are, but the best ones are lithium. They are very expensive, and of course, you should also plan for backup. Don't just also plan for redundancy. Yeah, just don't go for leave some space for expansion. At least should supply outages for it should supply outages. That's my daughter. And of course, you should prioritize reliable brands. Of course, you should use to make prioritize reliable brands, and also you should optimize installation for efficiency. That means you should have enough roof space. Orientation, you should also secure the mounting, and so those are some of the tips. So So generally, for example, if you have that means that, for example, if you have, sorry for that. Now coming to the cost, it's essential to understand the rough estimates how much you would spend, because there are different kinds of there are cheap brands which you pay around 100 to where you pay the in charger, the charge controller, everything will come around 120. But there are other if you want to have, let's say, 5 hours of backup, or you have or 5 to 10, 12, 24 hours. Like for example, a scenario where you want a 24 hours off the grid will be, you'll be having like an inverter of 4.5 kV to 6 kV. Let's assume you go with the 4.5 kV, which will be costing around 300k to 300k to 200. It will cost from 200 to, let's say, 400k, but generally let's go with 370k. Then you need a solar panel, and then the solar panels, for the calculation, you calculate per watts. Like ours, what we have, we have solar panels for 40 to 60. We have for 60 watts. Indeed, there are also other brands where you'll be paying like 100 watts. So, but let's generally go with the standard 60 watts per. So that will translate to 1800 times 60. So that will be 180,000 Kenya shilling. And then you add the charge controller. The charge controller, assume you have a 12 volt 60 ampere controller at, let's say, around 24,000 shilling, around there, 24,700, around there, 24,000 shilling. Then you add the battery storage. The battery storage is, I assume that you go with the 248 volts, 200 amperes. So amperes is the current. So amperes, you get 248 volts, 200 ampere hour. So this you multiply the amperes in hour. Lithium ion battery. So with this one, you'll be spending around 150,000 shilling to 250,000 shilling. So that will be totaling around 300 to around half a million Kenya shilling. And so you add the installation fees, you estimate it to be around 50 to around 60, so around there. So the total cost will be, without battery storage, you have something around 550 Kenya shilling, inverter plus panel plus controller plus installation. But without battery, it will be, with battery storage, if you come now with the battery storage, you are dealing with something around 800 to around a million. So that's it. That's a simple one. And if you want to have some also, which we are also looking into, you can go with Tesla Solar Roof. But Tesla Solar Roof is not well entrenched in Kenya, but still, we have some friends whom we are able to install these Tesla solar cells. Myself and another guy whom we collaborate with, and that goes around 21 to 45 per square foot. Remember ours, the other we had quoted that 60 per watt. So when you calculate all that, you find that you'll be, for that 1500 square feet. So considering a 1500 square foot in Kenya home, you will need around 31,000 to around 40. So that translates to 4.5 to 5 million. On the higher end, 10 million to be off total grid. So the comparison, you better go with the 4.5 kilowatts inverter plus the other things. So that is the controller and the solar compared to the solar roof. I hope someone will come up with something which will be able to lower down these Tesla solar roofs. That's it. In case you have any query on the solar, in case you're interested in solar installation, home automation, alarm installation, home intruder, like in my back. If you check in my room, in my house, we have those vibration sensors. A vibration sensors in our room. There's a motion sensor in all areas. Maybe I can show you from there. I hope you can see the motion sensor from there. Yes, you can see at the corner there. That thing there is a motion sensor. So we do home automation.